Next, number 21. We have a diagram and we have to find the value of x and y. So we can clearly see that it's a rectangle, so opposite sides are equal. So I can write x plus y equals 30 and x minus y equals 14. To solve them, we will add the equations. Why we will add? We will add because y variable gets cancelled. So when x plus x is 2x, 2x equals 44. So x equals 44 by 2, which is 22 centimeters. Substituting this value in this equation number 1, I will get 22 plus y equals 30. So y equals 30 minus 22, which is 8 centimeters. Then next question is number 22. We have to find the value of x in terms of a, b and c. So a, b and c are the given distances and we have to find the value of x in terms of a, b and c. So we can say that here, given these two angles are equal, angle LMK is equal to angle PNK, and angle K is equal to angle K, which is a common angle. So by AA similarity criteria, we can say triangle LMK is similar to triangle PNK. When they are similar, the sides are proportional. So LM by PN is equal to KM by KN. So this is nothing but A by X is equal to B plus C by C. Now I need to find the value of X. So I will cross multiply. So X times B plus C is equal to AC, or X is equal to AC over B plus C. Okay. Next, number 23. The question says X, Y and MN are the tangents drawn at the endpoints of the diameter DE of the circle with center O. Prove that XY is parallel to MN. So let us draw the diagram first. We have a circle with center O. It says XY and MN are the tangents drawn at the endpoints of diameter DE. So this is my diameter DE and XY and MN are drawn. Now we have to prove that XY is parallel to MN. We know that OD is perpendicular to XY. Radius is perpendicular to the tangent. Similarly, OE is also perpendicular to MN. Therefore, these two angles are equal, 90 degrees. So these two angles are nothing but alternate interior angles, right? We can consider any two angles as alternate interior angles. So I can say that angle EDX is equal to angle DEN, which is 90, and they are alternate angles. So when alternate angles are there, the lines are parallel to each other. Hence proved. Okay. Next, number 24. So it says a rope by which cow is tethered is increased from 16 to 23 meters. How much additional ground does it have now to graze? So first thing is, the rope is increased from 16 meters to 23 meters. So we have to basically find the difference between the area. So area of a circle, because the rope is tied to the cow and cow will move in a circular manner to graze, right? So this small r is 16 and now it is increased 23. So now the capital R is 23 meters. So the area of the bigger r minus area of the smaller radius. So pi into 23 square minus pi into 16 square. So 23 square is nothing but 529 and 16 square is 256, and we take pi common. So my answer is pi into 273. If I consider pi as 22 by 7, so my answer comes out to be 858 meters square. Okay. The OR question says, in the below figure, OACB is a quadrant of a circle with center O and radius 3.5. If OD is equal to 2 cm, find the area of the quadrant OACB and the shaded region. So area of the quadrant will be 1 by 4 pi r square since it's a quadrant. So 1 by 4 into 22 by 7 into r. So radius is 3.5, which you can write it as 7 by 2. So if I cancel out everything, I will get answer as 9.625 centimeters square. Second thing, you have to find the area of the shaded region. So I have to subtract the area of the triangle from the shaded region. So area of the triangle will be half into OB into OD, area of triangle, BOD. So half into OB will be the radius itself, 7 by 2, and OD is given 2 centimeters. So my answer comes out to be 7 by 2 again, so which is 3.5 centimeters square. If I subtract 3.5 from 9.625, I get the area of the shaded region, which is nothing but 6.125 centimeters square. Okay. Next, question number 25. Find AB if sine of A plus 2B is equal to root 3 by 2 and cos of A plus B is equal to half. So in this case, we have been given sine and cos. We know that sine is root 3 by 2 when angle is 60 degrees. So A plus 2B is equal to 60 degrees and cos A plus B is half when it is again 60 degrees, right? So A plus B is again also 60 degrees. So we have two equations. So if I subtract the equations, A gets cancelled, B is equal to 0 degrees. So when B is 0, substitute the value. In the first equation, A comes out to be 60 degrees. Okay. Now the OR question, which says if 1 plus cos A times 1 minus cos A is equal to 3 by 4, find the value of tan A. So we know that 1 plus cos A, 1 minus cos A, it is A plus B, A minus B formula, which is A square minus B square. So A square minus B square is equal to 3 by 4. 1 minus cos square A is nothing but sine square A. So sine square A is 3 by 4. So sine A is how much? Plus or minus root 3 by 2. If I take square root both. Sine A is plus or minus root 3 by 2. So if I consider a triangle, this is my plus or minus root 3 and this is 2. So this will be 1 using Pythagoras theorem. So tan A will be perpendicular by base. So plus or minus root 3 by 1, which is plus or minus root 3 only. Okay. Next, question number 26. We have to prove that root 5 is irrational number. So let us consider that it is a rational number in P by Q form, where P and Q belong to integer and Q is not equal to 0. Now let's consider P as Q root 5, cross multiplying. Taking square both sides, I will get 5Q square. So by this we can say that P square is divisible by 5. Therefore, P is also divisible by 5. Right? So let us say P is nothing but 5m for any multiple of 5 and m is a factor. Now, if I square both sides, I will get P square equals 25m square. But we have P square is equal to 5Q square as well from this equation. Therefore, I can write 5Q square is equal to 25m square. Right? So from this, I can say that my 5Q square is equal to 25m square. Hence, q square is equal to 5m square. So q is also divisible by 5, and hence p and q both are divisible by 5, which is not possible because p by q form is the simplest form of representing a rational number. There should not be any common factor. So hence it is not possible. P and Q have to be co-prime numbers. So root 5 is irrational. Next, number 27. Find the zeros of the quadratic polynomial. So quadratic polynomial is given. We have to find the zeros and verify the coefficient relationship. So to find the zeros, we will use the splitting of the middle term method. We can use the formula method also. So here, coefficient of A times coefficient C, which is nothing but 18, minus 18. I need negative 7. So the factors of 18 are 1, 18, 2 and 9. I can clearly see that if I use 2 and 9, I can get negative 7. So I will write 6 square minus 9x plus 2x minus 3. From here, 3x is common. So I would say 2x minus 3. From here only 1 is common. So 2x minus 3. Now 2x minus 3 is common in both the case. What's left? 3x plus 1. And this equals 0. So using this bracket, x equals 3 by 2. And using this bracket, x equals minus 1 by 3. So these are my two zeros. Now I have to prove the relationship. So sum of zeros, considering alpha plus beta, has to be minus b by a. So 3 by 2 minus 1 by 3 is nothing but somewhere around 7 by 6. And minus b here is minus of minus 7 by a, which is 6, which is 7 by 6. So this relationship exists. Next, product of zeros. So product of zeros, alpha into beta is equal to minus 1 by 3 into 3 by 2, which comes out to be minus half. Now c by a I have to check. What is my c? Minus 1 and a is 2. This relationship is also verified. Next, number 28. A part of monthly hostel charges in a college is fixed, and the remaining depends on the number of days one has taken food in mess. When student A takes food for 22 days, he has to pay 1380 as hostel charges, whereas student B, who takes food for 28 days, pays rupees 1680. Find the fixed charges and the cost of food per day. So let the fixed charges be X and the cost of food per day be Y. Food per day. Now, as per the question, fixed charges plus 22 days for A, the cost is 1380. Second condition is X plus 28Y is nothing but 1680. So I have two equations. I have to solve them. I will simply subtract. So if I subtract, I get negative 6y is equal to 300 minus 300. So 6y equals 300, y equals 300 by 6, which comes out to be 50. Therefore, for 1 day, they are charging 50 rupees for food. I will substitute the value in the first equation. So x plus 22 times 50 is equal to 1380. X plus 22 into 50 is nothing but 1100 is equal to 1380. X equals 1380 minus 1100, which is 280 rupees. This is the fixed hostel charge. Number 28 or question. The ratio of income of two person is 9:7. So let the income of one person be 9x and second person be 7x. And the ratio of the expenditure is 4:3. Expenditure. If each of them manages to save 2000 rupees per month, find their monthly income. So first thing is, what will be the saving of the first person. Let us consider expenditure ratio as 4y and 3y. So income minus expenditure is saving. So income of first minus expenditure of first is equal to saving. Similarly, income of second minus expenditure of second is equal to monthly saving. I have got two equations. Now I have to solve them. So to solve this, I will multiply the first equation by 3, second equation by 4. What will this do? This will equate the y coefficient and we can easily solve them. So it will come 27x minus 12y equals 6000. 8x minus 12y equals 8000. Now I'll subtract them. So I'll get minus x equals minus 2000 or x equals 2000. Therefore, the value of x is 2000. I will substitute the value of x in the first equation to get the value of y. So I will get 9 times 2000 minus 4y equals 2000. 18,000 minus 4y equals 2000. 4y equals 18,000 minus 2000, which is 16,000. So y equals 4,000. I need to find their monthly income. So 9 times x, which is 18,000, is the monthly income of the first person, and 7 times 2,000 equals 14,000 is the monthly income of second person. If they ask you expenditure also, you can put y and get the answer. Next, number 29. We have to prove that sine theta minus cos theta plus 1 is equal to sine theta plus cos theta minus 1 is equal to sec theta plus tan theta. Now, I know that I want sec and tan form. So to convert sine into tan, I have to divide it by cos. And 1 by cos is sec. So my intention is to divide the whole thing by cos. So dividing the numerator and denominator by cos theta, I will get tan theta minus 1 plus sec theta over tan theta plus 1 minus sec theta. Now, I can write 1 as sec square theta minus tan square theta. So I will write here tan theta plus sec theta minus sec square theta minus tan square theta using the identity. Similar, and the denominator remains same, tan theta plus 1 minus sec theta. In the numerator, you can see that sec theta plus tan theta is common because this is a square minus b square, which is a plus b into a minus b. Sec theta plus tan theta is common. Here is also sec theta plus tan theta. If you expand the bracket, I'll get sec theta plus tan theta, which I take common. So what's left? 1 is left. 1 minus sec theta plus tan theta. A square minus b square formula. So what I will get? Tan theta plus sec theta minus sec theta plus tan theta into sec theta minus tan theta, and the denominator as it is. So sec theta plus tan theta is common. I can write this as sec theta plus tan theta, right? I can rearrange it. Right. So my sec theta plus tan theta is common. What is remaining? 1 minus of sec theta minus tan theta. 1 minus sec theta minus tan theta. Further solving it, I will get sec theta plus tan theta, and if I open the bracket, I would get 1 minus sec theta plus tan theta. And my denominator is also the same thing, tan theta plus 1 minus sec theta. If I rearrange this term, it is 1 minus sec theta plus tan theta, which gets cancelled, and I get the answer as sec theta plus tan theta is equal to RHS. Hence proved. Okay. Next, number 30. Prove that intercept of a tangent between two parallel tangents to a circle subtend a right angle at the center. So we'll consider a circle, center be O, diameter be PQ, and the tangent is XY and X dash Y dash. Now making a triangle. So we have been given that XY and X dash Y dash are two parallel tangents to the circle with center O. AB is a tangent at point C which intersects XY at A and X dash Y dash at B. And we have to prove that intercept of tangent between two parallel tangents to a circle subtends a right angle in the center. So our aim is to prove that angle AOB is 90 degree. So we have AP equals AC. AP equals AC, tangents from the same point. Similarly, we have PO equals OC, radii of the circle. We have OA equals OA, common side. So in triangle OAP and OAC, they are congruent by SSS criterion. So CPCT will be angle AOP is equal to angle AOC. Hence, we can also say angle BOQ is equal to angle BOC. Right? So what will happen? POQ is the diameter of the... Now if I consider AOC as angle 1 and BOC as angle 2, PQ is a straight line. So I would say since these two angles are equal, so this whole angle will be 180. Angle in a straight line is 180. Right? So I will write angle 1 plus angle 1 plus angle 2 plus angle 2 is equal to 180, or twice of angle 1 plus angle 2 is 180, or angle 1 plus angle 2 is 90, which is nothing but the center angle at the center AOB. Hence proved. Okay. Now next is our question. Prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. So let us consider a quadrilateral ABCD. Which has a circle inside it. Now, the circle touches the quadrilateral at PQRS. And let us join the vertices of the quadrilateral to the center. And the diagonals also. Now, in triangle OAP and triangle OAS, AP is equal to AS, tangents from same point, PO equals OS, same radius, OA equals OA, common side. So by SSS they are common, they are congruent. By SSS condition they are congruent. So triangle OA is equal to angle AOS by CPCT. Let us name the angles, number them in clockwise: 1, 2, 3, 4, 5, 6, 7 and 8. So I can say that here angle 1 is equal to angle 8. Okay. Similarly, by proving them congruent, I can say that angle 2 is equal to angle 3, angle 4 is equal to angle 5 and angle 6 is equal to angle 7. Now, sum of all the angles is 360. I will say angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 8 is equal to 360. Now I can write twice of angle 1 plus angle 2 plus angle 5 plus angle 6 is 360. So angle 1, 2, 5 and 6 is 180. Therefore, angle AOD plus angle COD is 180, which is nothing but angle BOC plus angle DOA is 180. That's what we had to prove. Okay. Now question 31. One card is drawn at a random from well-shuffled deck of 52 playing cards. Find the probability of card drawn is either a red card or a king. So how many red cards do we have? We have 26 red cards, right? And kings are 4. And including the red cards, we have only 2 extra kings of black. So total cards are 28. And our total number of outcomes will be 52 cards. And favorable outcomes are 28. 26 red plus king and 2 black kings. So this I will get 7 by 13 probability for the first part. Second part, neither a red nor a queen. So probability of neither a red card nor a queen card. So again, red is 26 only. Black queens are 2, so 28. I don't need this, so I will subtract this from the total, which is 24. So these cards are not red cards and they don't have any queen as well. So 24 over 52, which is 6 by 13 is my probability for the second part. Okay.